Okay, so if you tried those problems on page 4, here are the answers. I will also scan this into a PDF file, and I will put this on Canvas so that you can have the answer key and all the completed notes. Okay, so I'll briefly just show you in this YouTube video, but you can also go to Canvas and just look at the PDF file. A through L all over here. Okay, so I want you to either email me or just add comment on, I guess, under this YouTube video or on Canvas if you want me to go over any one of these. Okay, all right. I'm gonna go over limits involving infinity, and I think in this video I will just go over example 4 and 5. Okay, I'm gonna try to just have short videos covering a little bit each instead of like a long, super long video, like hour and 30 minutes long, covering everything else. So in this one, let me go over example 4, limits involving infinity. Now, I do want to go all the way up to that one box that we talked about over here. Theorem 1. Limit exists if the left-hand limit and the right-hand limit equal to each other, and there was one part right here that this limit has to be a real number. So if they're both approaching, let's say, any real number, like 2 from the left and 2 from the right, then the limit is 2. If they're both approaching other real number like pi or any real number, then the limit does exist. But we're going to look at some cases like positive infinity and negative infinity. So technically, those are not real numbers. So it's okay if you want to say it does not exist. But we will use those symbols, positive infinity and negative infinity over here. So let's take a look at this rational function, f of x equals 1 over x minus 2 for the first one, okay? I do have the graph there, and we can also look at the limit graphically. We want to find, let's take a look at the first one. Find limit as x approaches 2 from the left, right? What does that mean? Start from a number that is smaller than 2. Start from a number that is smaller than 2. Like what? 1.9 is smaller than 2, right? But just get really, really close to 2. So I'm getting a little bit bigger each time, all right? To get close to 2. 1.9, 1.99, 1.999, and I just keep on going. Now, if you plug in, and it's not magic, I really just plugged in those numbers into the function. If you evaluate 1 over, because the function is 1 over x minus 2, if you do evaluate 1 over 1.9 minus 2, and if you get the decimal value, that is negative 10, okay? But seeing only one number does not really help, because we want to see a pattern, right? If you plug in the next number, 1 over this number right there, 1.99 minus 2. If you plug this into your calculator, you will get negative 100. Oh, we're seeing a pattern now. One more, if you plug in 1 minus, the next x value is 1.999, and you subtract 2. If you type this into your calculator, they will give you negative 1,000. And the next number is negative 10,000. Can you see the pattern here? Let me erase some random stuff here. Okay, so if you are guessing, I'm guessing 1.12345 nines after it, I am thinking the next number will be negative 100,000. Okay, imagine keep on going this way. Okay, if you keep on getting really close to 2, what are these y values doing? They're getting smaller like crazy, right? If you keep on going down, okay, if you keep on getting smaller, can you see that f of x is approaching negative infinity? So that's what we're going to tell them. We're going to tell them that the left-hand limit as x approaches 2 is negative infinity. If you can see that in the graph over here with me. So here is 2, right? Here is 2. If you approach 2 from the left, look at the graph. The graph is going down. Okay, it's just going down like crazy. Why? Because we do have a vertical asymptote at x equals 2. Okay? So the graph is approaching negative infinity to the left of 2. And now we can look at the right-hand limit. The right-hand limit as x approaches 2. Okay, so start from a number that is slightly bigger than 2. So we start from 2.1, but I'm going to get closer to 2. How about 2.01? It's a little bit smaller than 2.1 because I'm trying to get close to 2. 2.001 and next 2.0001. I guess I can keep on going. 0.00001. You know, every time we add an extra 0 in front of that 1, we are just getting close to 2. At that point, it's like almost 2. But if x is doing that, and if you plug in these x values in there, 1 over 2.1 minus 2, and you plug this into your calculator, that will give you 10. And you keep on going. 1 over 2.01 minus 2. And thank goodness we did this beforehand, so we don't have to sit here and type these in the calculator, right? So that will give you 100. Every time you type in these numbers that are getting, just getting close to this limit 2, can you see that f of x, the y values are just getting big, right? So if you keep on going down, what are we approaching? F of x is approaching a big number, a positive infinity. So, and that should match in the graph too, right? So take a look at the graph of f of x. As we approach 2 from the right, trying to get close to 2, you see how the graphs, skyrocket up, all the way up. It's approaching positive infinity right there. So, what happens? Does the general limit exist? That's the last question right here. Does the general limit exist? It does not. No. Because negative infinity does not equal to positive infinity, I can say that the left-hand limit, which is going to negative infinity, does not equal to right-hand limit. And not only that, infinity is not a real number, right? Because remember, we said in Theorem 1, the left-hand limit and the right-hand limit, if they are equal, the general limit exists, but that L has to be a real number. So technically, the limit does not exist if it's going to. We say they diverge. We'll talk more about that. But for right now, well, this problem, it just does not exist because the left-hand limit and the right-hand limit, they're not even equal to each other, right? All right, let's look at another one down here. Oh, this one's slightly different, guys. Okay, this one's slightly different. And we're going to have so much fun evaluating limits involving infinity in section 1.2 next week. Let's see. Let f of x equals 1 over x. It's another rational function, right? Where is the vertical asymptote at? The vertical asymptote is at x equals 0, right? But looks like we're not really looking at x equals 0 this time. Where are we trying to go to? Look at this first part. Find limit as x approaches what? X approaches positive infinity. So I need to talk about this. I want to talk about this with you. What does that mean? X is approaching positive infinity. This means, guys, remember we graph the x values on the horizontal x-axis, right? That's the x-axis. So if x is approaching positive infinity, take a look. 1, 2, 3, 4, 5, 6. If it's going to positive infinity, this means we are going to the right side. Going to the right side of these x-axis because that's where we keep the big numbers, okay? So this means right end behavior. X approaching positive infinity means we're looking at the right end behavior of this graph. And in Math 161, you learned about end behavior. So let's look at this graph because I have the graph right here. As I am approaching the positive infinity, do you see that this graph is getting it's getting really, really close to this x-axis, but it's not really going to cross the x-axis, right? So we can say the right end behavior of this f of x is equal to 0. Because it's getting really, really close to this y value of 0, y equals 0, as we go to the right side. So the first answer is 0. But we can look at this graphically too. Numerically too, by plugging in some numbers if the graph is not convincing. Take a look. Let's make the x really, really big. Start from 100. 100 is already a big number. But if you plug in 100 into this function, you have 1 over 100, which is 0.01. Next, let's plug in a slightly bigger x value. If you do 1 over 1,000, That is 0.001. Lastly, I guess we can plug in another big number, 10,000. 1 over 10,000 is 0.0001. Do you guys see that f of x is really approaching what number? It's approaching 0. Okay, so both numerically and graphically. In our Zoom meeting, we went over graphical limits, numerical limits, and hopefully on these lesson videos for that asynchronous part of the class, I want to go over these graphical limits. So please do watch that first video. We went over how to read limits graphically, okay? All right, let me come back and finish the rest of it. How about, how would you read this symbol? Okay, and what are we talking about when we are saying x is approaching negative infinity? This means, okay, x is going to negative infinity means x is getting smaller. -1, -2, -3, -4. So if you want to go smaller on the x, you are going to the left. Okay, you're going to the left. So this means left end behavior, okay, of this graph. What is this graph approaching to the left end? If you keep on following this graph to the left, do you see that it's trying to come up, but it's not going to really cross that line at y equals 0. So it's approaching 0 too. So we can also look at it graphically. If you plug in these x values into the function, you'll have 1 over -100, which gives you this decimal. But as you can see, these are negative decimals, but these numbers are getting close to what? Negative 0.000000 at some point, right? But negative 0.0, I mean, can you see that it's approaching -0? But -0 is just same as 0. 0 doesn't really have a symbol, a sign. So we can look at it from the table to that numerically, this limit is approaching 0. But we're not going to be able to talk about general limit because we weren't approaching infinity from the left or to the or from the right. So we're not going to be able to say, you see, we didn't really have symbol like minus sign right there or a plus sign right there. So these were not, they were not one-sided limit. In fact, you can't go to the right side of positive infinity, right? Positive infinity is the far right. It's just a concept. It's not really a real thing. So we're not going to be able to say, like how we always did, one-sided limit from looking at, the general limit by looking at the one-sided limits first. All these updates on my iPad, I'm sorry. But for this one, this is all we get to do, okay? This is all we get to do. So I think I sprinkled in a couple of these infinity limits on your assignment. So if you need more help, just please reach out to me. We will come up with more examples, or we will go over those problems that you need more help with, okay? All right, I'm going to go ahead and look at that. Frank just submitted his daily problem. That's great. I'm going to come back and record the last video where I go over example 6 and maybe example 7 in another. But hopefully you guys are watching and this is working out okay, all right?